Now let's define a function for solving problems. It's called tree search because it superimposes a search tree over the state space. Here's how it works. It starts off by initializing the frontier to be the path consisting of only the initial state. And then it goes into a loop in which it first checks to see do we still have anything left in the frontier. If not, we fail. There can be no solution. If we do have something, then we make a choice. And tree search is really a family of functions, not a single algorithm, which depends on how we make that choice. And we'll see some of the options later. We go ahead and make a choice of one of the paths on the frontier and remove that path from the frontier. We find the state which is at the end of the path, and if that state's a goal, then we're done. We found a path to the goal. Otherwise, we do what's called expanding that path. We look at all the actions from that state, and we add to the path the actions and the result of that state. So we get a new path that has the old path, the action, and the result of that action, and we stick all of those paths back onto the frontier.
The function tree search takes in one parameter, problem. Inside the function, the first line is to let frontier equal the initial state. The second line is loop colon. The next line is if the frontier is empty, the function returns fail. The next line is path equals remove choice of frontier. The next line is s equals path.end. The next line is if s is a goal, then return true. The next line is for a in actions colon. The next line is add action A to the path and add the result state of taking A to the frontier.
Now, tree search represents a whole family of algorithms. And where you get the family resemblance is that they're all looking at the frontier, popping items off, and looking to see if they're goal tests. But where you get the difference is right here, in the choice of how you're going to expand the next item on the frontier. Which path do we look at first? And we'll go through different sets of algorithms that make different choices for which path to look at first. The first algorithm I want to consider is called breadth first search. Now, it could be called shortest first search because what it does is always choose off the frontier one of the paths that hasn't been considered yet that's the shortest possible. So how does it work? Well, we start off with the path of length 0 starting in the start state. Now that's the only path in the frontier, so it's the shortest one, so we pick it, and then we expand it. And we add in all the paths that result from applying all the possible actions. So now we've removed this path from the frontier, but we've added in 3 new paths. This one, and this one.
The title of this page is Breadth First Search. It shows the same road network in Romania. First, the city Arad is circled and it is in the frontier. Then it is removed from the frontier and its 3 neighbors are added to the frontier.
Now we're in a position where we have 3 paths on the frontier and we have to pick the shortest one. Now in this case, all 3 paths have the same length, length 1, so we break the tie at random or using some other technique. And let's suppose that in this case we choose this path from Arid to Sibiu. Now, the question I want you to answer is, once we remove that from the frontier, what paths are we going to add next? So show me, by checking off the cities that end the paths, which paths are going to be added to the frontier.
If we want to remove Sibiu, which is the neighbor of Arad, from the frontier in the next step, which cities should be added to the frontier?